All right. So we're going to look at basically a build off of the sign law called the ambiguous case. Ambiguous means that you're not sure. It could be multiple things. And when we get through this explanation, it'll make sense. But essentially, when you're given a question, sometimes there's two triangles. Okay? And one of them is invisible. It's hard to see. And we need to be aware that they exist because you'll lose half the marks in a question if you don't. So I have an example drawn here. What I need you to understand is that for ambiguous triangles, there are no diagrams. So whenever you get one of those questions where it says like, oh, the first side is 8 and the angle is 33 degrees, you need to have a warning bell go off and say, okay, is it ambiguous? Because it might be. If it gives you a triangle with all the numbers written on it, your life is easy. Just solve that. There's only one triangle. They gave you the triangle. Okay? We need to worry about when it's the stupid word questions. So let's say they gave me a word question. They said one side is 10. We'll call it side B. One side is 8. And then angle A is 40 degrees. I took the liberty of drawing a sweet diagram already. What you'll notice is that they gave me an angle and an opposite side. This is important. The other thing that's important is that this number was smaller than this number, this side. I am going to demonstrate how this triangle is only one of the two diagrams possible. I'm going to draw the 10 and the 40 degrees again, but that 8 side, I'm instead going to draw like this. What I would argue is that these three pieces of information are the same in the two triangles, but there's no way to know which triangle they're talking about. So unless a question specifically says something that makes it so that only one of these is possible, so for example, it says all the angles are acute or something like that, you have to assume both are needed and you need to talk about both, which means it's a double question in disguise. Kind of a clue is when you have a question that's worth more marks. So let's just say you had a sign law question worth 4. Then the next one's worth 6. And you're like, why is it worth so much? It might be because it's ambiguous. Just think about it. So the way that these work, when you solve this triangle, let's actually solve this one, okay? So I'm going to set up my sign law. Sine A over A, sine B over B. I'm going to sub in my numbers. So again, I got my matching pair right here. I'll call that A. Oh, sorry. Let's sub in the numbers. Sine 40 over 8 equals sine, we don't know, B over 10. So when I rearrange and solve, I am going to get, let's just double check. I got 53 degrees. Okay, great. So think logically for a second. I don't know which triangle I'm looking at, except when you think about it, you really do. Because this angle opposite from 10 is what we just calculated. This angle is obviously acute. This angle is obviously not. It's obviously obtuse. So this 53 we found was this angle. What I'm going to tell you is whenever you have an ambiguous triangle, it always looks like this, in that it could either be that way or it could be that way. When you find the first angle, when you just do sign law without thinking about it, it gives you this 53. It didn't give you this hidden triangle. This is the secret triangle, okay? The one hidden inside of it. What we need to do now is figure out how to find out what that angle is. The way it's going to work, we know these are both 8, so we know that this has to be 53 because that's how isosceles triangles work. If that's 53, I know that, let's do red. I know that these two angles are 180 degrees because it's like a flat line. So I do 180 minus 53, which is the angle I found over here, and that's going to give me 137. Nope, 127. That was bad. 127. That's that angle there. So what you need to do is that once you have the two triangles, so we did this acute one, and we did this obtuse one. That was terrible, sorry. Okay, 127, 53. Using those angles we found, we can then find the rest of the missing information, okay? Because we'll be able to figure out that top angle and then figure out the bottom side that we didn't know. I'm not going to go through that process, but that's how you do ambiguous cases. So the big question is, how do you tell? Okay? We did an example where it was. The way that you can tell is when that first side, it gives you this angle. When that opposite side, opposite the angle, if this, let's call this A, because it gave us angle A. When A is less than B, when it's any number smaller than B, that means there's two triangles. Okay? When A is smaller than B. So if this was 10, this was 8, yes. If it was 10 and it was 12, no. The reason for this is because if this number is small, it can flip and fit here. If the number was big, so it was 10 and like 20, there would still be a triangle. It would just be like this. If we tried to flip it the other direction, it would go this way, and then this angle wouldn't work anymore. So if it's a huge number, there's only one triangle. Okay? So if it's small, we need to realize that it could be here too. It's actually possible to be too small as well. So if we had 10 here, the idea is that the smallest this side could be is to make a right angle triangle. If it was shorter than that, this little stubby line or this little stubby line, like if it was 1, it's too short. It won't make it so that this angle would be 40 degrees. Okay? If you want to know what this height is, you just use trig ratios to figure it out. So you would say sine 40 is equal to opposite over hypotenuse and rearrange. So in this case, this is opposite, this is hypotenuse. Opposite is equal to h sine 40. So if you do this ratio, if you need to figure out if a triangle is possible or if it's like a gibberish triangle, then you can do this to figure it out. There is one more example of ambiguous cases. They come up more rarely, but in word problems. They usually describe like two people standing just near each other, and you usually have to find this distance. And it describes them looking with angles at a point. Okay, and so it gives you this angle, let's say like 72 degrees and 81 degrees, I don't know, whatever. This is ambiguous because the other way you could draw it is this way. Okay. Because of this, you need to be careful when they give you word problems, and usually the question you always just think about is, could I draw it another way? If you could, try to draw it another way by just putting a vertex you put somewhere really weird and see if it makes a different triangle. If you can draw it two ways, then there's two triangles. It's always possible with ambiguous case setups like this. And that's it.